For generations, we've looked up at the night sky and believed our galaxy, the Milky Way, was a vast cosmic empire, a sprawling collection of hundreds of billions of stars stretching far across the universe. But recent astronomical discoveries have revealed something surprising and a little humbling. The Milky Way may not be the colossal giant we once imagined. In fact, scientists now say our galaxy might be much smaller than we ever thought. This revelation doesn't just change a number in a textbook, it reshapes how we understand our place in the cosmos. For decades, astronomy textbooks described the Milky Way as a barred spiral galaxy with a diameter of roughly 100,000 to 120,000 light-years. It was believed to contain 200 to 400 billion stars, along with a massive halo of dark matter extending far beyond the visible stars. The Milky Way was often portrayed as a cosmic heavyweight, a typical large spiral galaxy, comparable to the Andromeda galaxy in size. For a long time, this model held up well. But that was before we had precise measurements of the galaxy's edges, structure, and motion. Over the last decade, a new generation of telescopes and instruments has revolutionized how we measure the size of galaxies, including our own. The Gaia spacecraft, launched by the European Space Agency in 2013, has been mapping more than 1.8 billion stars in unprecedented detail. It tracks their positions, brightness, and motions with extraordinary precision, allowing astronomers to create a 3D map of the Milky Way like never before. Meanwhile, radio telescopes, like the Very Large Array in New Mexico, have helped trace the outer hydrogen gas that defines the galaxy's disk. And powerful supercomputers have simulated galactic dynamics using these measurements. Together, these technologies have revealed a more accurate, and more surprising, picture of our home galaxy. I would be very grateful if you could like the video and even subscribe, as it really helps the channel. Thanks so much. For a long time, the Milky Way's size was somewhat arbitrary. Where does a galaxy end? Is it where the stars thin out? Where the gas ends? Or where the dark matter halo fades into intergalactic space? Recent research has shown that the stellar disk of the Milky Way, the flat plane containing most of the stars, is actually around 80,000 light-years in diameter, smaller than previously thought. But what's more surprising is the behavior of the outer regions. Instead of smoothly extending outward, the disk warps and tapers off, forming a kind of stellar frontier where stars become scarce. Beyond this frontier lies mostly diffuse gas and dark matter, but not the dense, star-filled spiral arms we once imagined. In short, our galaxy's real star-filled structure is smaller and more delicate than the grand spiral often depicted in illustrations. If we include the invisible dark matter halo, the vast, spherical cloud of unseen mass that surrounds the Milky Way, then the galaxy's total reach is enormous, up to 1.9 million light-years across. But that's a very different kind of size. The halo doesn't contain stars or gas in a way we can see, it's inferred from the motion of stars and satellite galaxies. So while the gravitational influence of the Milky Way extends far, its visible, starry heart is much smaller. This distinction between visible size and gravitational size has become crucial in modern astronomy. For years, scientists believed the Milky Way and the Andromeda galaxy were roughly the same size, two cosmic titans destined to collide in about 4.5 billion years. But new measurements suggest Andromeda is actually significantly larger and more massive than the Milky Way. Its stellar disk may span more than 220,000 light-years, nearly twice the size of our galaxy's disk. It also likely contains more stars and a more massive central bulge. This makes the Milky Way the smaller sibling in the upcoming galactic merger, not the equal partner we once imagined. It's like discovering that the house you've lived in your whole life is actually half the size you thought, and your neighbor's house is towering over it. One of the most fascinating ways scientists have traced the outer limits of the Milky Way is by studying stellar streams, long, thin trails of stars created when smaller galaxies are torn apart by our galaxy's gravity. By tracking these streams, astronomers can map the gravitational field of the Milky Way far beyond the visible disk. What they found is striking: the stellar disk ends more abruptly than expected, while the dark matter halo continues, ghost-like, much farther. These streams act like cosmic tripwires, revealing the true shape of the galaxy's outskirts. The result? A more modest starry domain than previously believed. So why did astronomers overestimate the Milky Way's size for so many years? Part of the answer is our position inside it. Measuring the shape of the galaxy from within is like trying to map a forest while standing among the trees. Early estimates relied on stellar density and radio emissions to guess where the disk ended, but these methods weren't precise enough to reveal its subtle warp and thinning edges. As telescopes improved, particularly with Gaia's precise measurements, we could finally see the galaxy's contours with clarity. And what we found was a smaller, more complex, and slightly warped structure, not the perfectly flat, grand spiral once drawn in textbooks. There's something poetic about this discovery. For centuries, humanity has slowly learned that our place in the universe is not at the center, not of the solar system, not of the galaxy, and not even among the largest galaxies. Realizing the Milky Way is smaller than we believed is another reminder of our true scale in the cosmos. We live in a beautiful galaxy, yes, but it's not a galactic superpower. And perhaps that makes it even more special. In its modest size lies a unique history of star formation, mergers, and cosmic evolution. Scientists are still refining their measurements. New missions, like the Nancy Grace Roman Space Telescope, will offer even more precise data on the Milky Way's structure and halo. But one thing is clear: the image of our galaxy is changing. It's smaller, more intricate, and more dynamic than the simple diagrams of the past. This new understanding doesn't make our galaxy any less fascinating, it makes it more real. And as our instruments sharpen and our maps expand, we'll continue to uncover truths about our home in the stars that surprise us, humble us, and inspire us. Because even if our galaxy isn't the biggest, it's ours. And that makes it remarkable.